We're being asked here to sketch a couple of exponentials on the same set of axes. So before we start, we should probably keep our standard rules in mind. And the first one is, of course, to remember whenever we're transforming that it's always nice to go with Dr. T, which means we're going to do things in the order of dilation, then reflection, and then translation. I'm going to start with my first graph, this y equals 2 to the power of x plus 3. And this was originally y equals 2 to the power of x. Then when I added the 3 up here, that means I've translated it across by 3 to get y equals 2 to the power of x plus 3. So 3 units to the left. So if I wanted to sketch 2 to the power of x, I might sketch a graph that looks something like that. And this would pass through the points 0 and 1. So therefore, if I move it across 3, it might go through a point here, and it would look something like this. In fact, let's make it a solid line. So it might look something like this. And therefore, this point here will be at -3 and 1. And that's my y equals 2 to the power of x plus 3, unlike this one, which is y 2 to the power of x. Now let's look at our other function. This here, if we imagine that this started off as y equals 2 to the power of x, and then we keep in mind this idea that functions that have been transformed follow the basic formula of y equals a f to the n x minus h plus k. It seems here that my n is going to be 3, my h is -3, and my k is -1. Now this n, this is the dilation from the y-axis. Okay, 1 over n actually is the dilation from the y-axis. So therefore my dilation from the y-axis will equal 1/3, which is a compression. So that means when I operate this, which is what I have to do first, my original line, which is this dotted line, will become dilated. So it's going to look more like this. It's squished up and it'll go more like this where it comes out that way. Now the next thing I'm going to do is I'm going to move this across by 3 units and down by 1. So my new asymptote is going to be at x equals -1, so y equals -1. And I'm bringing this function down and across. So my point here that was at 0, 1 is still going to be at -3 and 1 as I move it across 3. And then it's going to move down by 1. So it's actually going to cross my x-axis at -3. So my function will be squished and moved, and it's going to end up looking something like this. If that makes any sense. Let's try and make it a little bit nicer. So there's an exponential, and it's this light blue line that's been moved, and this now is y equals 2 to the 3x plus 3, and then move down by 1 unit. Now, we could work out the y-intercept, but because exponentials rise so quickly, we'd probably find that this value would be a very high value. In fact, it would be 2 to the power of 3, 0 plus 3 minus 1, which is 2 to the power of 9 minus 1, which I think is 511. So it's no surprise my y-intercept is off the graph. However, my x-intercept will be at -3 and 0. If you found this video helpful, please subscribe or like. Thanks.